All right, we have a whole bunch of aerodynamics coming to you, and we're going to be doing breaks in between the aerodynamic videos, giving away study guide, more towards the end probably, some t-shirts and some books. So let's get started. Aerodynamics, this is good stuff. Go ahead and roll it, Heather.
So real quick, here are the parts of an airfoil. Up front here we have the leading edge, and you just think about it, it leads the airfoil through the air. Back here we have the trailing edge, which just trails behind the leading edge. The upper camber is the upper curvature, and the lower camber is the lower curvature. Now if you take a line and go straight from the leading edge to the trailing edge, this is the chord line. Now what I've drawn here is a symmetrical airfoil, in that the upper and the lower are the same. Now if I draw an asymmetrical airfoil, it would look something more like this. If I draw the chord line, you would see that the upper camber and the lower camber look different. So this is an asymmetrical, this is a symmetrical. So now we're going to talk about some basic aerodynamic terms. Now the real key to understanding this and honestly teaching it is to make everything come to this point back here. It's not really exactly how it works in real life, but it makes drawing it and teaching it a lot easier. So we're going to start with our chord line, goes up through the blade. Down here, this is our plane of rotation. This is the actual plane that the rotor blade is moving through the air. Now, just because a rotor blade is moving through the air like this, doesn't mean that that is necessarily the angle the wind is striking it at. It's not necessarily coming like that. Depending on if you're climbing, descending in an auto rotation or whatnot, the wind might be striking it at different angles. So we have what we call the relative wind. So this is the actual angle that the air is striking the rotor blade. Now between the relative wind and the chord line, this is your angle of attack. This is where we get our lift from. Now down here, this is what we consider to be our induced flow. Induced flow is actually bad. We do not like it. And you can see if you have more induced flow, you have less angle of attack, meaning you have less lift. Now your overall angle from your chord line to your plane of rotation, which is your overall, this is a mechanical angle, it's not an aerodynamic angle. This is your pitch angle. And that is just simply how much pitch you have compared to the plane of rotation. So now we're going to talk about drag. The first one we're going to talk about is parasite drag. This affects any non-lifting parts of the helicopter, the cabin, the skids, the mast, basically anything that is having to be pushed through the air. Just like you're driving down the road, you stick your hand out the car window and it gets pushed backwards, that's parasite drag. Now I have a graph here. This is airspeed and drag, so this will be faster and faster, and this will be more and more drag. Parasite drag starts off low and it goes up very quickly. Parasite drag actually is squared, which means that if you double your airspeed, you will quadruple your drag. The reason being is that, and everybody always thinks it's just double, you double your airspeed, double your drag. It's actually quadruple. So if you go from 40 knots to 80 knots, you have 4 times more parasite drag. And here's a good example of why. I had a physics teacher in high school, Mr. Hughes, here's a shout out to you if you ever see this. And he said if you're driving, picture you're driving in a convertible and you are taller than the window. And you're driving through a tunnel, and suspended in the tunnel are basketballs every 10 feet. If you're going 10 miles an hour, you're going to go thump, ow, thump, ow, thump, ow. Now, if you double your speed, you're going to hit those basketballs twice as often, ow, 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 and you're going to hit them twice as hard, ow, it's going to hurt more. So that's why it's quadrupled. You're hitting those air molecules twice as often and twice as hard. That's why it's 4 times when you double your airspeed. Next, we're going to talk about induced drag. Induced drag is a byproduct of lift. So if you have an airfoil and you draw the lift, it's actually going to be perpendicular to the chord line. So its total lift is going to be straight through the blade coming out. Now the problem is that that is vertical, which is what we want, but then also this right here is the induced drag. So if you picture your hand out a car window, you put a little bit of pitch in it and you're going to get lift, but it's also going to be dragging backwards. Now the more you tilt that airfoil, the more that lift gets tilted back and back and back, and the more induced drag you have. So what happens with induced drag is that this one actually starts high at a low airspeed and then drops off the faster we go. So if you picture yourself, you're in a hover, you're pulling up a lot of collective, there's a lot of pitch in the blades, which means there's a lot of drag pulling those blades back, which means it takes a lot of engine power to push those blades through the air. You get up into forward flight, and you can see you can reduce a little bit of pitch, which means that lift is rotated forward a little bit, which means you have a little bit less induced drag, requiring less engine power. So this drag starts high and then drops off with airspeed. Now we're going to talk about profile drag. Profile drag has two different parts: form drag and skin friction. Form drag is simply what happens to an airfoil as it's flowing through the air. So these are all taken right out of the Rotorcraft Flying Handbook if you want to follow along with me. If we have just like a flat plate like this, you can see the air hits it, goes around, and it's very turbulent on the back side. Then if you take that same diameter and you round it out, you can see it gets a little better, but you're still getting the separation on this side, and then the air is coming together and mixing. So that's why they make an airfoil this shape. It minimizes the separation right here, and then when it comes together, you have the least amount of turbulence on the backside. You will still get some turbulence on the backside no matter what, but we minimize it. So this turbulence on the backside kind of slows this airfoil down a little bit and puts a little bit of drag on the backside. So that's the form part. Skin friction, no matter how smooth your rotor blade looks, if you zoom in on it and you look at the microscopic detail, it's always going to have little jagged little bits, and the air gets caught up in those and causes a little bit of drag. So these two together make profile drag. Profile drag only affects airfoils, so we're talking about airfoils here. So what I've done is I've graphed all the drags. Now as a note, profile drag stays pretty low until you really get to higher airspeed. So it's not really super bad in our speed range, it's mostly higher airspeed that starts to come in. So we have parasite drag, which starts low and takes off really quickly. Remember, it's squared. Induced drag actually starts up high and then drops off with forward airspeed. And then we have profile drag, which slowly starts to eke up at higher airspeeds. Now what you do is if you average all of these together, you'll get your total drag curve. So average all these together, and that is this. So this is our total drag curve. Now you notice, contrary to what you would think, oh, zero airspeed down here would be the least amount of drag. It's not. The lowest, we call this the low point on the drag curve. And the low point on the drag curve in the R22 Beta 2 is 53 knots. Ding, 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 ding. That's our best rate of climb airspeed. So if you want to climb as fast as you can, you fly at 53 knots and you are using the least amount of energy to just keep yourself flying, which means you have the most amount of energy available to then climb. So that's basically the most efficient aerodynamic airspeed for the helicopter. Another note that 53 knots is also our least rate of descent in an auto rotation. So if you enter an auto and you slow it to 53 knots, that is the slowest descent rate you will have in an auto rotation. So now we're going to talk about how lift is actually produced by an airfoil. Now we have two things, the Venturi and the Bernoulli. A common misconception, people lump these two things together. They're actually two different things, but they do work together. So Venturi states that as air goes through a constricted area, its velocity increases. So if I draw a classic Venturi like this, and we have air going across it, you can see here it's going to increase its speed as it goes through here. Now, you don't actually need both sides of the Venturi for this to take effect. You can do it with just this, which is an airfoil. You can see how as air goes over the top of the airfoil, its speed increases versus the air that goes on the bottom is not going to increase in speed. Now Bernoulli figured out that as airspeed increases, pressure decreases. So you create a low pressure here and a high pressure here, which creates lift. Now let me draw it with an airfoil that we would actually use. And you can see here as the air goes over the foil, it increases in speed. As air goes under the foil, it will go slower. Think of it this way. The air going over the foil has to get from here to here, which is a much further distance than the airfoil going underneath it just has to get from here to here, so it doesn't have to go as fast. Another way to think about it is think of your hand as like a waterfall. As air goes over your hand like this, your airfoil, it's going to fall off the backside, increasing its speed. As speed increases, pressure decreases, so you have a positive down here, negative up here, and that creates lift. Now, we get about, it depends on the situation and what book you read, but approximately we get about 70% of our lift from this. The other 30% we get just from Newton's third law, which means every action has an equal and opposite reaction. We are taking air and we are deflecting it downward. Air has mass, it weighs something. So just like if I sit in a rolly chair and I have a bowling ball and I throw the bowling ball that way, I move backwards. If your helicopter takes that air and throws it down, it'll help push the helicopter up. So this is about 30% of where our total lift comes from.
All right, a whole bunch of more aerodynamic videos coming to you. This won't take long. I'm going to give away a copy of Top 10 Check Ride Tips next. We're highlighting today Private Pilot 1-year special. Right now, only $397. That saves you $767 off a normal yearly if you were paying going monthly all year. And we want to review. We've got some new numbers for you in the Private Pilot course. So go ahead, Heather. This is the Private Pilot course, which includes quizzes now. We have quizzes on the full course at the end of each lesson. There's 18 lessons. There's a quiz at the end of each course. Student progress tracking. So as you watch the videos, it'll show you which videos are completed, how much of the video has been completed. Have you watched a quarter? Have you watched a half? That's awesome. We also have resume course on any device. You can log off the computer, go to your phone and log back in, hit resume course, take you right back to where you were. Mobile app for all devices, so you can do it you can work with HOGS on a laptop, desktop, or you can actually go to the mobile app that we have. When you log into the site, there's a blue line at the top where you can actually download the app, and then we send you a welcome email that also gives you a link to the mobile app. Also with the Private Pilot course, which is a full-blown Private Pilot course, you get the Robinson R22 specific course, you get the Robinson R44 specific course, you get an instrument specific course, and a radio communication course. And we've just figured out there's 195 videos just in Private Pilot. That doesn't include the Robinson videos or the instrument videos. So Private Pilot alone is 195 videos, and then it's 48 hours of training for the private and all the supplemental videos combined. FAA written test practice. All of those have been updated on all of our HOGS courses, private, commercial, CFI, instrument. All those courses are updated with new FAA written test practice. All of those are at the end of each course, so go through the full course of training, take the FAA written test practice at the end, and it's available for FAA Wings credit. So once we got looking at everything, it's just fun to realize how far HOGS has come and what all we have available. So also a new community that's new and more robust than the original community. That's up and running. We're going to start doing some more stuff in there to get people activated and up and running. Comes with a 30-day no hassle money back guarantee. And if you have a question, you can text or call Heather at 574-767-1797. So the Private Pilot special yearly is good till January 1st, New Year's Day, midnight. So for the top 10 check ride tips, we simply want to know and answer in chat, and Heather will declare the winner in chat. So we're going to roll the next set of videos, and the question is, what's my favorite color? All right, roll the videos, Heather. Dave Redmond did an incredible job, did he not, on digging into lift and drag. I just want to sum up these 4 videos, give you some things to think about, what you're going to need to actually know. Dave digs in there. You know, at the private level, you're not going to be up there drawing on the board like he did. At the private level, you need to know some basic stuff. Then at the commercial, you'll need to know it even better. And then, of course, at the CFI level, then you're up there drawing the board. So some really great presentations by Dave. What I want to follow up with is the 4 forces. You have to know that at the private level. They're going to probably ask you, what are the 4 forces? Lift, weight, thrust, and drag. Lift is the force that overcomes the weight, and thrust is the force that overcomes the drag. Lift is the force that acts upward on the helicopter, opposes weight. Weight is the force of gravity that pulls down on the helicopter. It opposes lift. Thrust is the force that propels the aircraft in a particular direction. It opposes drag. Drag is the force that resists movement in any direction. It opposes thrust. An airfoil is any shape or surface used to create lift. Dave mentioned symmetrical and asymmetrical or unsymmetrical. Here's an example of a rotor blade, symmetrical, and an airplane wing for the asymmetrical. Angle of attack, chord line, relative wind. You're going to need simple definitions for these. Angle of attack, angle between the chord line and the direction of the relative wind. Chord line is a line going through the center of the rotor blade from the leading edge to the trailing edge. And the definition for relative wind is the airfoil in relation to the direction of the surrounding air. So there you go on the 4 forces of flight. Let us know what you're thinking, what you like, what you want to see that maybe we haven't covered quite yet. Put them in your comments in the description box below, and we'll see you in the next video. Helicopter streamlining is a term that you're going to hear when you get into more of like when you're taking your test. The examiner may ask you about helicopter streamlining. This is a pretty simple subject. We know you're learning a lot of stuff with aerodynamics, so don't let this one overwhelm you. This is going to be pretty quick. In the section on helicopter controls, you are going to learn about how you use the pedals to operate the anti-torque rotor or the tail rotor, and at slow speeds, you use those pedals to make adjustments with the nose left and right on the helicopter and control the nose of the aircraft. Basically though, when you get moving at forward flight, like say 60, 70, 80 knots, you then have what they call streamlining of the fuselage. And later you're going to learn about helicopter emergencies, and you're going to learn about what would happen if you lost that tail rotor during flight. If you have forward airspeed, like we're talking about, 60, 70, 80 knots, something like that, you just have to think about the airflow passing down the side of the aircraft, okay? So sometimes the question will be, well, if you're forward flight and you lose your tail rotor, how come it doesn't just start to spin? Why doesn't the aircraft start spinning out of control? It's not going to when you have a lot of forward airspeed, because if you think about it, streamlining the fuselage is simply the airflow going down past the cabin of the aircraft, and that nose is pointing into the wind, so it's not going to get, even if you lost the tail rotor, it's not going to move much. It might move a little bit, but at forward flight, it's not going to move much because you have this airflow going all the way down the side of the aircraft, and you even have back here what we call a horizontal stabilizer. Some helicopters have vertical, some have horizontal. So you've also got stabilization back here as well. So when you hear the term helicopter streamlining, not much to it. And that's why in forward flight, you can actually have a tail rotor failure, tail rotor drive shaft could break, tail rotor could fly off. With forward flight, you're still going to be able to keep flying pretty straight, and you can continue to fly until you can find a good place to do an auto rotation landing. And you can do that because you've got that airflow going down past the sides of the helicopter. That's helicopter streamlining. All right, we're going to shoot a new translating tendency video for you today. The one that we've had in the site for a while is kind of old. So what we're doing is we're taking this lesson right out of the helicopter flying handbook. A lot of times I bring down the iPad. Today I'm just using the good old fashioned paperback because we like both, right? We like having it on the iPad, like having it on the I like having the paperback copy. So when you go to the helicopter flying handbook to check out translating tendency, the first thing they do is give you the definition, and then they show you the overview of the blade rotation, torque, drift, tail rotor downwash, and tail rotor thrust. So we're going to go down there, point these things out to you, and we got a tip from our examiner on the thrust issue that people are screwing up on check rides, so we're going to make sure we cover that with you. Yeah, I'm liking it. So the first thing I want to point out is blade rotation. So you got to think about which aircraft are you flying, which aircraft are you talking about in your discussion about translating tendency or drift. We're using the instrument in this example. This is a counterclockwise system, right? So the blades are moving this way, right? So we have the engine and transmission driving the rotor system. So as that rotor system is going counterclockwise, the torque is wanting the aircraft and nose to go to the right. Blades are spinning this way, nose wants to go to the right. We can understand that, that makes sense. So we have to counter effect that torque. And the way that we counter effect the torque is the tail rotor, also called the anti-torque rotor. Even though we're talking about translating tendency or tail rotor drift, we just want to point out this quick point, because it shows us right here. Tail rotor downwash, tail rotor thrust. And people are messing this up on check rides, and our examiner said, please, when you're doing your videos, start really pointing out these things that people are struggling with. So the tail rotor's back here doing its job. It's pushing against the tail boom, okay? So it's counteracting torque by pushing against that tail boom. What's coming this way is just downwash, dirty air, tail rotor downwash. A lot of people on check rides, when the examiner says, which way is the thrust, they say this way. But that's not the case, and it shows us right here in Helicopter Flying Handbook. Tail rotor thrust is going this way. This is just turbulent air coming away from the tail rotor. So in the Enstrom, and this is what we're using for this example, hopefully in the shot, you're able to see that that rotor mast is rigged just a little bit to the left. So when the tendency of the helicopter to drift to the right, in this instance, because the tail rotor is pushing against the tail boom, Enstrom counteracts that tendency by leaning the rotor mast a little bit to the left. In other aircraft, it may be done through cyclic rigging. Some aircraft, they don't even counteract it at all. I flew a BK-117 for a couple years, and they told us in training with the BK-117, that's not built into that system. So that skid's always hanging low on the left, your right skid always comes up first, and you're always holding to the left to counter-effect that effect of torque. So depending on the aircraft you're flying, you need to know how they compensate for that in that aircraft. So to sum it up, people screw up all the time between translating tendency, effective translational lift, and transverse flow effect, okay? So also know for your check ride preparation, those three get confused many different times. They get jumbled together with people on a check ride. So on this one, this is translating tendency. And just think of it again one more time. That tail rotor is pushing. It has tail rotor thrust against the tail boom. So the aircraft is going to want to drift to the right during a hover. So depending on what you're flying, you're either going to have to hold in left cyclic. Part of this may be done by the aircraft. By the way the aircraft's built, it's either going to be through rigging of the mast, rigging of the controls, or maybe not at all. What is translating tendency? Your textbook definition right out of the Helicopter Flying Handbook, the tendency of a single rotor helicopter to move laterally during hovering flight, also called tail rotor drift. It's one of the 3 T's that everybody screws up: effective translational lift, transverse flow effect, and translating tendency. And in this helicopter, this is an Enstrom, they rig the mast slightly to the left to compensate for translating tendency. Depends on what aircraft you're flying. Some aircraft have a change in their rigging to compensate for it. There are some aircraft that they don't compensate at all. You just hold the cyclic to keep the aircraft centered. So if you've struggled with this, don't feel bad. Everybody messes up the 3 T's. Am I in the shot?
Yeah.
Okay. All right, so even though we're talking about this is going to go at the end. This is going to go at the end. So even though we're talking about translating tendency, I can't say it. I think that's okay. Heather is across from me chatting with you in chat. If you just came to this video, Heather's in chat. We're asking questions, giving away prizes, and you're going to answer in the chat. Not for you today is some hovering with one of our new students. This is one of our instructors out. This gentleman's in his second. Heather? Yep. Pop your number in there. Heather's been with us almost 5 years. You can get a hold of her for any questions. I had a member on a video yesterday mentioned, hey, how do I upgrade? We said in the video, contact Heather, text or call, numbers on the screen. So as we mentioned, the private pilot is an awesome special. We're also going to mention real quick, professional pilot with just lifetime membership, no bells and whistles, no extras. Still a good deal at $977. That link is down below the video. So we're going to ask our next question, and then we're going to get back to some more aerodynamics. We are showing you is all content from our private pilot section. And last year we updated a bunch of the aerodynamic sections where we kept Dave Redmond because people love Dave, and updated with my daughter's uncle, an artist, did some drawing for us to make the presentations a little more exciting and more visual for your learning. So the next question is, for the helicopter check ride, again, play in chat, we have to have a flight review every 24 months. What must that flight review consist of? Type that in chat. Go ahead and roll the next series of videos, Heather, and we'll be back for some more giveaways. What we have for you today is some hovering with one of our new students. This is one of our instructors out. This gentleman's in maybe his second or third lesson, and he's just getting in his introduction to hovering. So I thought many of you would like to see what it looks like from the outside when somebody's learning to hover. Maybe you're new to this and you're getting ready to give it a try, or maybe you're already flying a helicopter and want to see what it looks like outside and remember back what it was like when you first started to learn. The whole trick to learn to fly these things is smooth control inputs. And when we start you out, like in this gentleman's case, we let you work the collective for a little bit, we let you work the pedals for a little bit, we let you work the cyclic for a little bit, and then we start putting those together. And like in this video right now, I believe he's probably working a little bit with the collective. Now they're working with the pedals. And as the flight goes on, usually we'll give you a little more. We'll then double up and say, okay, now you got the pedals and the collective. And we kind of mix it up like that. And then at a certain point, as you get more on your plate, more things to do, and get more tired throughout the lesson, things just start getting uglier as your flight goes on. But this is totally normal. Learning to hover one of these things is one of the hardest things that you're probably going to ever do in your life. And in the beginning, when you first start to learn, you think, oh my God, I'm never going to get this. This is just too flipping hard. But the more you do it, the more you practice it, the better you get. One of the things that you'll learn about is pendular action. And you can see that in this video. Anytime that they're out there, as it starts to move, it'll start swinging. It'll go forward, and then it swings backwards. Maybe it goes to the left, and then it goes to the right. That is what we call pendular action. And that is a normal thing that you're going to go through when you're learning to fly these things. Is you're going to just be swinging that aircraft, swinging left, swinging right, swinging forward, swinging back.
Good sized aircraft, so you got to think about this aircraft has a center of gravity and it's suspended by the rotor system. So you got this one tube going up and it's attached to the rotor system. So all of that weight is hanging off that point right up there. So that should help give you a little more idea of when a new student's in there, and if they're over controlling and they're moving the controls too much, it all just starts swinging, you know? It's swinging around, hanging, suspended by that one spot.
So I can take a smaller
toy. I can't obviously just pick the helicopter up and do that, but weight suspended by the rotor system. So when you start over controlling, that thing is going to be moving all over the place. And it usually happens from a new student who's just making too large of inputs on the controls. Now, it's not necessarily new students. This could be somebody who maybe hasn't flown in a while, and they'll pick it up and they'll start kind of wobbling around. They'll start uncontrolling. Somebody that hasn't flown in the recent past, or maybe it's been a few years since they've been up, they'll get out there and start doing that. But it will smooth out and it'll get better as you get more experience. So the goal, of course, is to not swing around. Students learning to hover will experience this due to too late, too strong, or too long of control inputs. So the whole trick when you're in here on the controls, the cyclic and the collective, is just to make nice, smooth movements. And as you get more and more experience, it will come, and that crazy oscillating pendular action will go away. So it all comes from just over controlling and moving these too much. Basically, we say it's more like you're willing it to move than to make it move, to get it smooth and get a nice smooth hover going. So it is a normal thing that a new student goes through. Just remember, you have a lot of mass, a lot of weight hanging off that one point on the rotor system. Smooth control inputs are key.
Oh, we're recording here.
Yeah, it'll hear us. Okay, though.
All right, that opening footage was from the Coffee with Kenny series of videos on YouTube. And in those 3 clips, you just saw the 3 elements of coning. The examiner may very well ask you about the 3 elements of coning during your private pilot check ride. So let's talk about those 3 elements, give you a demonstration. So the memory aid I used when I was learning all this stuff was I thought about weight, the helicopter sitting stationary, it's not running, and the blades are drooping down. The weight of the blade itself is just kind of hanging down. And the weight again plays also into the 3rd element of coning, which is lift. But we're going to go through each one of them. So this is how I remembered it. Then the next stage of coning is centrifugal force. Now you've got a pilot in the aircraft, blades are spinning, but you're not applying any lift yet. So due to centrifugal force, the blades are spinning outwards due to that force. Then in the next stage, the 3rd element is lift. Once you've applied lift and you've gotten the helicopter up off the ground, in this example in a hover, the blades are going to cone up due to lift and the weight of the helicopter is being suspended by that rotor system. Now, depending on which helicopter you're flying, they could be coning up due to hinges that are allowing them to move up, or they could be coning up through bending of the blades. So those are three elements important to understand: weight, centrifugal force, and lift. And if the examiner asks you what is coning, it's very simply what happens in the rotor system when the weight of the helicopter is being suspended by the rotor blades. And in turn, they cone up. So memorize the three elements of coning: weight, centrifugal force, and lift.
So next we're going to talk about Coriolis effect. Now, we have another video on blade flapping and dissymmetry of lift and why the blades flap, so I recommend watching that video before this one. But now we're going to go into what happens when the blades flap. Now, when a blade goes up or down, all of our blades have a center of mass. You can think of it as like the center of gravity, or where the blade would balance if you put it on a point. Well, when the blade flaps up, you can see this moves inward a little bit. So it gets a little bit closer. Now, if you picture like an ice skater and they're spinning around, and when they pull their arms in, they spin faster and faster, and then when they let their arms out, they slow back down. So when you have a center of mass move closer, the blade wants to spin quicker. Now, the different rotor systems deal with this in different ways. A fully articulated actually has a hinge right on the blade that allows it to what we call lead and lag. And so as the blade flaps up and wants to go a little faster, it's allowed to lead a little bit, and then when it flaps back down and that center mass moves back away, then it's allowed to slow back down a little bit. A rigid system doesn't have a hinge for lead or lag. It just actually bends one way or the other as it wants to accelerate or decelerate. Now, the R22 doesn't have either of these things, and so it has another way of dealing with it. Now, we have what's called an underslung rotor system, which means it's not like the rotor comes right into this pivot point. Ours is more like the blade comes in, attaches, and it's below, it's actually below down here, not up here. Now you can see as the blade, if we didn't have that, the blades would go like this. And that center of mass would get closer as it flaps up. So what you actually have to do is push the blade away to keep that center of gravity from getting closer. So our blade doesn't do this, it actually does this as it flaps. So you can see here, as this blade flaps up, it doesn't just come in, it actually goes out in a way like that. So if I draw this thing flapped up, and I were to draw the center of gravity, in both of these situations, the center of gravity does not get any closer or further away, because as it flaps up, it gets pushed out a little bit. So it keeps the center of gravity the same distance, so the R22 does not experience any Coriolis effect. The blades do not need to accelerate or decelerate at all.
And we're back. All right, next giveaway is going to be for a HOGS t-shirt. So real quick, before I answer the question and move on to the next videos, $397 for a full year of private pilot. We showed you at the last break. Everything that's included, 195 videos alone in private pilot. It's a lot. We've figured out that in the pro pilot course, 608 videos over 100 hours in the pro pilot. Okay, we're going to keep moving. The question is, I just renewed my CFI over the weekend, so I have a lot of fresh stuff in my mind. Is the flight review, is there a pass or fail grade? This is a yes or no answer. Very simply, is the flight review, is there a pass or fail grade? And we'll go on to the next video. All right, next we want to talk about gyroscopic precession. This will be a pretty short video. Gyroscopic precession is a pretty easy principle, but you're going to hear it over and over again, and it applies to all the other aerodynamics that we talk about. So in this video, we're going to go to our new diagram made by our illustrator Ken Penn. All right, gyroscopic precession. For this presentation, we're using a counterclockwise rotor system looking down from above, okay? So these arrows here are showing how the rotor system is spinning. In this scenario, we want the helicopter to move forward. So we're going to need less lift at the front of the rotor system, and we're going to need more lift at the rear of the rotor system. With gyroscopic precession, when you apply a force to a spinning object, it's felt 90 degrees later in the plane of rotation. So to get the aircraft moving this way, we need a forward cyclic input to get the aircraft moving. The manufacturer has built the rigging so that when the cyclic moves forward, it increases the pitch of the blade right here, giving you more lift. So when you apply force here, it's then felt 90 degrees later here at the rear of the rotor disc. So less lift in the front, more lift in the rear, helicopter moves this way. So the examiner is going to ask you on your private pilot check ride, what is gyroscopic precession? The very simple answer, all you have to know, it's when a force is applied to a spinning object, it's felt 90 degrees later in the plane of rotation. And then if he wanted you to talk a little more about it, simply you could explain it with a diagram just like this. Pretty simple stuff. But again, this is going to tie into so many of the other videos and aerodynamic principles that we talk about. So that is gyroscopic precession. Nice. All right, next thing we want to talk about is gyroscopic precession. All right, let's talk about the symmetry of lift. A lot of people like to call it difference in lift. So for our demonstration today, we're going to talk about a counterclockwise rotor system. Looking down from above, this would be spinning counterclockwise, okay? So the blade on this side is your advancing blade. This blade here is going to be moving into the wind. The blade over here on the other side, we call this the retreating blade because it's actually moving away from the wind. So you got advancing blade, retreating blade. Next, we want to talk about tip speed. So for this example, we're going to use 500 even for the speed at the tip of this blade, okay? So your advancing blade moving at 500 knots, the retreating blade will be moving at 500 knots as well because we're in a hover, no wind, okay? Blades are spinning as we just talked about, tip speed's 500. What happens when we add a little bit of wind? So we're going to put an arrow at the top here to signify 30 knots of wind moving towards the nose of that aircraft. Okay, so what's happening? As this happens, you have to take that 30 knots of wind and add it to the 500 knots because of that relative wind coming at meeting the blade that's advancing. That makes a tip speed of 530 knots. Now the retreating blade is moving away from that relative airflow, so that you would subtract, and that side makes that 470. Okay, so now you see we have a difference in lift. With just that 30 knots of wind, no big deal. Now we want to change the scenario to the helicopter flying forward at 100 knots. So it's flying through the air at 100 knots. So you got to think about your advancing blade meeting that relative wind at 100 knots. That makes the tip speed 600 on the advancing side. Now on the retreating blade, that is retreating away from that relative flow of air. So that's going to make that side tip speed 400 knots. So now you can see the difference is getting greater the faster you go. So in this video, we just wanted to simply help you understand what's going on with the rotor system, how this airflow is working, and that the faster you go, this starts becoming a problem because you have to start worrying about something called retreating blade stall. And we go into more into this in detail. The examiner is going to ask you about retreating blade stall, and there's a lot of other aerodynamic principles that take place as this helicopter is moving forward through the air. There's blade flapping and other things going on. So this video is just to give you a general idea of why they have the term dissymmetry of lift and why they say difference in lift.
So now we're going to do a video on a helicopter going from stable hover flight all the way through ETL and what happens aerodynamically and what happens to the ship. So for these scenarios, we're going to pretend like there's no wind, so dead calm, and we're going to start off in a hover. So step one, we are just in a hover.
Look, it does work.
Gotta do it before you set it.
Shit, I screwed up that. Whoops. Sorry, everybody. I messed up. Let's start that one over. Which video was it? This one?
MP.
All right, we got to start that over. I goofed. Playing with the controls when I shouldn't be. Here we go.
So now we're going to do a video on a helicopter going from stable hover flight all the way through ETL and what happens aerodynamically and what happens to the ship. So for these scenarios, we're going to pretend like there's no wind, so dead calm, and we're going to start off in a hover. So step one, we are just in a hover. Everything is pretty uniform. Air is coming down like this. Got our vortice, we're in ground effect. There you go. So that's kind of our starting point. Now and the term you want to say is with any horizontal movement, which means if you get 2 knots of wind, that will cause things to change, or if you just start going at a walking pace, things will start changing. So step 2 is any horizontal movement. I should say horizontal airflow. Now we're starting, and again, this can be just a walking pace. So we're starting to move forward. In the back half of the helicopter, really nothing has changed. Still coming down, going out. Vortice. Front half, mostly the same. Probably right here is the same, but then the air isn't quite coming straight down. Now it's starting to shift and come in a little bit more like this. And your vortice is being reduced a little bit and being blown away just a little bit. Now, when you change your airflow from coming straight down to a little more horizontal, you have reduced your induced flow. You can watch one of my other videos where I explain why reducing induced flow increases angle of attack. But when you reduce induced flow, you get more lift, so the helicopter wants to kind of pick up a little bit. Also, with a smaller vortice, it will produce a little bit more lift as well, and the helicopter, and you'll feel this if you do a nice slow takeoff, you'll feel the helicopter kind of at the beginning just kind of want to pop up a little bit. And that's getting any beneficial lift from any horizontal movement. Now we're going to start accelerating and going a little bit faster and a little bit faster, and we're going to get into a transverse flow effect. This happens between 10 and 20 knots. So what happens is you can kind of almost think of it as the front half of the blade is in clean air, the back half is still in dirty recirculated air. So we're starting to go a little bit faster. Front half is more kind of horizontal like this and coming through nice and pretty clean. The vortice has been blown away. The back half is still coming down like this because it hasn't fully been blown away, and you have a vortice. So you can think of it as front half clean, back half is still kind of dirty. 3 things happen here. 1, we get a shudder. And you'll recognize this as you start flying. You start taking off and you get a little vibration, a little shudder. What this is, and the way I picture it is, you have a blade and it's going back and forth between, oh, clean air, my vortice is blown away, I got good horizontal flow, not as much induced flow, oh, bad air in the back, I got a lot of induced flow, I got a vortice, not producing much lift. So clean, dirty, clean, dirty, clean, dirty. It's just the vibration of the rotor system going through that. The second thing is a right roll. Now, we talked about gyroscopic precession in another video, so you may want to review that. But if I look top down at the helicopter, so here's the body of the helicopter and the tail, and I have the blade, you're getting more lift at the front of the blade. But because of gyroscopic precession, that has a maximum effect 90 degrees later over here. So you have that increase in lift affecting you on the left side, which will cause the helicopter to roll to the right a little bit. Third thing, we have a left yaw. This tail rotor back here, remember, it's doing the same thing as the main rotor as far as pushing air, creating lift, all that kind of stuff. It has vortices, it has induced flow, and just like the main rotor. So as you start moving forward into clean air, those vortices will get blown away, the airflow will be more horizontal, not going straight in like this. So your tail rotor will become more effective, which means it's going to push harder, which means all that left pedal you have in for hover, now that tail rotor is going to become more efficient, so it's going to yaw you to the left. So as you're pushing through this, you need to be backing off that tail rotor and pushing some right pedal to keep your nose straight ahead. Now this is really a funky transition that takes a while for students to get through because they're not anticipating it. The nose will kind of dip up and they weren't anticipating, so they'll nose over, then it'll roll to the right, so they'll push left, and then the tail rotor will swing you to the left, so then you're too late pushing right pedal, and you get this kind of fishtailing weird thing until you've blown through it. The key to learning this is to slow it way down. All students who are just going too fast and they can't anticipate, if you slow it way down and you just start creeping forward like a grandma would start learning how to fly, and you'll start to feel the shudders, and then you can work your way through these things a lot easier, and then that will build the anticipation to where you can be like, oh, this is going to happen. Next we get to ETL, which is just effective translational lift. So this is effective translational lift. This is now happens between 16 and 24. Now we have clean air going through the rotor system. Our vortices, we always have little vortices, but they're all but blown away. And now we have our induced flow has been greatly decreased. Remember, induced flow is bad, so we get rid of that, we get more lift. Our vortices are gone. Again, those are bad. We get rid of those, we get more lift. And this is where it requires a lot less power. Because the rotor system is more efficient, you can back off the collective and you can cruise along. This is why hovering takes a lot more power than it does to actually fly forward. Now notice these two, the airspeeds overlap, but these will never overlap. Basically, if you hit transverse flow at 10, you're probably going to hit ETL at 16. If you hit transverse flow at 20, you're probably going to hit ETL then at 24. You're not going to have both. It's always going to be this, then this. And this is why we like to get through to ETL to get into that clean air.
All right, on this break, we got to put up with the furnace running. Sorry, we tried turning it down in time. To reiterate on that last question, it's not a pass or fail on the flight review. Yes, the instructor could say, you know, you were a little weak today on the autos. Why don't you take a break and come back tomorrow and then we'll finish this up. But it is not a pass or fail grade. So the answer is no. It's not a pass or fail grade. Next question. Heather's going to have to remind me again. No, I remember what it is. For another t-shirt, again, play in chat, not in the comments below. Do you and your instructor, or should your instructor, be adding ground school in your pilot logbook along with your flights? Yes or no? So should you be putting actual ground time and subjects covered and dates in your actual pilot flying logbook? That's the next question. Yes or no? Go ahead and roll the next video, Heather. So let's talk about aerodynamically what's going on in the auto rotation with the helicopter. You know, people hear, oh, helicopters just drop out of the sky, and we know that's not the case. One of my instructors said back in the beginning, you can do everything without an engine that you can do with an engine except hold your altitude. And it makes a lot of sense. Once you get into this and you start flying and doing auto rotations, basically you can turn left, right, you can go forwards, backwards. You can keep the helicopter flying. And the reason is, as we're flying through the air, the helicopter is flying under power, and we're pulling air in through the rotor system, pushing it down, and accelerating forward. When that engine stops, of course, we start to descend. But that airflow, very simply, is changing from going right into the rotor system to all of a sudden doing this. That is why, as we start to descend, the rotor RPM starts to build. And if we put turns in there, it builds even more. So really simply put, the aerodynamically is that airflow is changing. Instead of coming in and meeting the blades, it's pushing up against them like a big fan. So it's actually making the blades spin faster. And that's what a lot of people first hear that, they're going, what? That sounds crazy. They think they just stop and fall out of the sky. I went through all my original training, doing the normal straight ins and 180s, all the things that we do in training, and even did some 90s. And when I was a new CFI, one of the first companies I worked for says, go out and fly with the examiner just for fun. And went out and he said, show me how you teach normal takeoffs and landings. And I did, and he goes, looks great. Let's go have some fun. Give me the controls. Takes me up to the numbers, above the numbers 3.6, whatever, we'll say maybe 500 feet. He's like, and comes to zero airspeed. He says, can I enter right here and land on those numbers 3.6? And again, I'm at the CFI level and I'm thinking, I guess you're getting ready to show me. He enters the auto rotation, he flies this way and flies backwards and does all this crazy stuff and then puts us right back over the number in a power recovery. First time that I saw how much you can really do without the engine. It is amazing that we can keep flying the helicopter and control the helicopter with that upward flow of air. The other part they talk about is hovering auto rotations. At this point, you're only a couple feet above the ground. And in the beginning, when you're new to this, it's pretty intimidating and it's hard people to get through hover autos, even in private commercial CFI. They really struggle and it's all about timing. And when that happens to you for real, I've only had it happen once where an engine failed during a hover, but it was after maintenance. And we're doing a hovering flight, hovering for a few minutes to make sure everything was good before we took off, because we would take off over a lake and the engine just quit. And I can tell you after practice, as a CFI, you're doing them all the time, you don't even think about it. Just the engine stops, you go right pedal and set on the ground. So being that low to the ground, even though it's intimidating in training, the more and more you do it, pretty soon you realize that the hovering out rotation really isn't a big deal because not a whole lot's going on. Engine quits, you're going to drop. If you keep the nose straight but it's pushing the right pedal, you're going to cushion it onto the ground. But that's just kind of the basics of why the aircraft keeps flying during an auto rotation.
Compliments of our operations manager, Brian Rutledge, who you probably know, or maybe not know if you're new to Helicopter Landing Ground School. Brian Rutledge is our operations manager. He built a presentation for us on auto-rotative descents to add to the aerodynamics section. So we're going to go out, talk about the presentation, and then show you a few things with the aircraft. All right, auto-rotative descents, auto-rotation. Descending and non-powered flight where the rotor RPMs come from the upward flow of air. Right now, we're flying along, getting ready to get set up for an auto. So at the beginning of an entry to an auto rotation, we're always going to do the same three things. Down collective, right pedal, and a little bit of aft cyclic at the entry. That airflow is going to change when we go from forward flight to descending. The airflow is going to change and start going up through the rotor system, driving the rotor system. We've taken away the engine power. We start to descend, the upward airflow keeps the blade spin, actually makes them speed up. So depending on what you're flying, you might be entering at 60 knots, 70 knots, depends on the aircraft.
Plymouth traffic, Aero 32622 is the left base, runway 28 full stop, Plymouth.
You'll enter the auto, and we'll take the camera down to the RPM and show you how that, usually we'll build just a little bit during the glide in a straight-in auto. In a 180 auto, during the turn, that RPM will always build, and we'll show you that too before we're done. So somewhere around treetop level, 40 feet, 50 feet, again, depending on what your aircraft manufacturer says, you're going to start a flare. And that flare is to slow the aircraft down to get ready to level it out and raise the collective, either to go to full touchdown landing or to a hover. Okay, so we had to give way for an airplane, so we're going to cover another slide here as Gary is getting set up for the auto rotation. So you're going to have some type of a freewheeling unit, no matter what aircraft you're flying. Different models have maybe different names or a different setup, but basically I think of it like a clutch in a car, right? If you're driving a manual shift, you push the clutch in, the engine and transmission are no longer married. So in a helicopter, same thing. When we enter auto rotation, it's like pushing on the clutch. The main rotor transmission is then no longer driving the rotor system. The rotor system is going to keep spinning from that upward flow of air.
Plymouth traffic, helicopter 8626 Papa will be on final for 28, Plymouth.
The freewheeling unit, located in the upper sheave, when the engine fails or when the throttle is closed in flight, the freewheeling unit disengages the rotor from the engine. Happens as soon as the RPM gets lower than the rotor RPM. Think of it like the rear hub of a bicycle. You can stop pedaling, but the bicycle keeps moving. So we're flying along, Gary's getting ready. We have 500 HEL. He has about 75 on his airspeed, which is good. We can enter a little bit higher than the glide speed that we want. So he's getting prepared, and when he enters, he's going to lower the collective, hold off a little bit of throttle. He's going to pull just a little bit of aft cyclic, and he's going to add some right pedal. We do this every time. All right, we're going to let Gary enter the auto rotation when he's ready, and our focal points are going to be airspeed and RPM.
1, 2, 3, all the way down, right pedal.
Okay, now that RPM is going to build because we're no longer flying with the engine, we're flying with the upward flare air will come up through the rotor system. So he's actually raising collective a little bit because the rotor system wants to speed up. So he's flaring now, he's going to level it out. Now he's bringing the engine back in, and we're back into a hover. So there's kind of the elements of the auto-rotative descent, and that's where we change from powered flight to non-powered flight, and that upward flow of air now going up through the rotor system.
Welcome back. This presentation we're going to go over autorotative descents, and we're going to speak specifically to the 3 regions of the rotor disc. For a vertical auto rotation with no wind, the rotor disc, you can divide this into 3 different regions. Now, the first one I'm going to show you is a vertical auto rotation in the no wind condition, and then when we talk about a forward auto rotation with some forward airspeed, you'll see that some things change in the diagram. So for this first one, first thing we're going to talk about is the stalled region. So you'll notice the stalled region, that is the center section of the rotor disc. And this is the area where it produces a large force against rotation, which is rotor drag. And approximately 25% of the total disc area comprises this area. The next section, which is the major portion in the center, this is what we call the driving region. It actually is good for us. This is what we want. It produces force in the direction of rotation, and you get about 45 to 75% of the total disc area. And this is the good stuff. This is what's actually providing the lift, providing the most force during the auto rotation. So it's driving the rotor system, which we really need in order to have a successful outcome. The last section is the driven region. This is going to be the area towards the outer section of the rotor disc, and this produces a slight force against rotation. Again, there's a rotor drag there, and it's approximately 30% of the total disc area. Now in forward flight, what you'll notice is the regions move slightly towards the retreating side. Now in this example, we are utilizing a counterclockwise rotating rotor system. So the advancing blade would be on the right side, moving towards the front, and then as it retreated on the left side, that's where you're going to see those forces slightly move to the left or towards the retreating side, and this is all because of dissymmetry of lift. Now, some things you do need to understand in regards to autorotative descents. When you raise the collective, there's less driving region available, and there's more drag, which causes your rotor RPM to decrease. You will actually decrease rotor RPM by raising the collective. Lowering the collective is more driving region available and less drag, which causes the rotor RPM to increase. Things you need to understand about autorotative descents and RPM control is raising the collective, RPM decreases. Lowering the collective, RPM increases. If you move the cyclic forward, RPM will decrease. If you move the cyclic aft or pull back on the cyclic, RPM will increase. Any turns that you make during an autorotative descent, RPM is going to increase. And if there's any wind gusts, your RPM can increase or decrease depending on how the wind's interacting with the rotor system. So with that is autorotative descents and the 3 regions of the rotor disc, and we'll see you in the next video.
Anthony, simple answer for your question. It's learning the proper control inputs and control management, and it should be through a lot of practice with your instructor during the auto rotations. I mean, it's learning to be on top of that RPM always and learning how to control it. Next question. Can you put the POH in the baggage compartment? Is it legal? You don't have a lot of room in there. Can you move your POH to the baggage compartment? Would that be acceptable? That's for top 10 check ride tips. Got your next video, rather heavy? Roll on next video.
All right, for this section, the last thing we're going to talk about is energy management. A helicopter must have height above the ground and or airspeed in order to have sufficient time and potential energy to perform a successful auto rotation when the engine fails. Operation in the shaded area of the high velocity diagram may not allow enough time to transition from powered flight to auto rotation. Following the recommended takeoff profile is important because takeoff is when the helicopter is most vulnerable to the difficulties caused by transition to auto rotation. And I want to talk about this takeoff that we just mentioned and the energy management. So what's important here is you want to take off staying within the takeoff profile for the aircraft you're flying out of that HV diagram. So on the instrument, what we do is we keep it close to the ground until around 30 or so, 30 or 35, then we start our climb. We're doing that to stay in that takeoff profile. Now what we teach all year round, summer or winter, doesn't matter. I'm always teaching the slow summertime takeoff. So we're keeping it close to the ground, keeping the nose straight, and we're just going to start moving forward very gently. If the engine quits, all we got to do is cushion the landing, add some right pedal, and we'll be just fine. So staying in this takeoff profile, we're just going to stay close to the ground, keep building a little more speed, a little more speed, a little more speed. Airspeed's right around 30 or 35, hitting 40, so now we're going to start climbing up. This is helping us stay out of that shaded area. Now I got some airspeed. If the engine would quit, I could flare and get it on the ground. I want to get to 60 as soon as I can, which today, like today, is easy. Boom, I'm at 60 already. I have a almost 500 feet per minute climb. It'll be there in just a second. Now the engine quits. We have a good chance at a successful outcome and getting the thing on the ground and getting out and walking away. If you pull too much power too first, put it nose low, and you have an engine failure, that could be ugly. If you go too high without getting forward airspeed and you lose the engine, that could be ugly too. All right, so you can thank Brian Rutledge for a lot of the new updates to the private pilot section. Gary and I are doing most of the filming, and Brian is the one, watching over us, looking over the private pilot, going, hey, you know what, I like this, but we need to update that. And we need to add this to a section. So we're really putting a lot of time and effort into update the private pilot section. So please put a comment down below and let us know if you notice the changes, what you like to see, and we'll see you in the next video. All right, we'll talk about rotor RPM for just a minute. Effective turns. We're getting ready to do a 180 turn, so we're going to show you something important. In order to turn, the disc must be tilted to push against the wind in order to accelerate the helicopter into the turn. This push will cause rotor RPM to rise. The collective must be raised in order to prevent rotor overspeed. As the turn is completed, the acceleration towards the center decreases and the rotor R will begin to decrease. The collective must be lowered in order to maintain rotor RPM in the green. Effects of flares. In order to slow down both the descent rate and forward airspeed, the disc must be tilted back against a wind. The energy of the descending ship gets transferred to the rotor blades, causing them to speed up. The timing and amount of flare must be controlled in order to speed the rotor system up just prior to landing, so as much energy as possible is stored in the rotor system in order to cushion the touchdown. Effects of up-downs and downdrafts. Updrafts and downdrafts encountered by the helicopter will be accompanied by increases and decreases in the rotor RPM. These must be accounted for by either raising or lowering the collective in order to keep the rotor RPM in the green.
I'll do a quick radio call. Plymouth traffic, helicopter 8626, Papa left downwind for 28, practice engine failure from the downwind. Plymouth.
All right, so Gary's getting ready to do a 180 auto rotation. So we're going to talk about the turn, talk about the RPM rising, and we'll talk about that flare and how the RPM raises in the flare as well. Okay, so very important here, anytime you do an auto rotation, you put a turn in there, that rotor RPM is going to increase. It's going to always happen. So we're going to try to catch that with the camera. We're going to try to know where the RPM is when we first enters, and then we're going to watch it rise a little bit during that turn, And then Gary's going to raise the collective to keep it from going past the limitation.
Degree 6 full stop by county.
Okay, I'm going to reposition my hand. 1, 2, 3, all the way down. Right pedal, get turning.
Okay, so note the RPM is low. He's starting his turn, and watch that RPM coming up. It's going to raise, so he's going to raise the collective so that the RPM doesn't go too high. He's getting ready to start the flare. And as he flares, it raises even higher, so he's going to have to raise collective, keep it from going too high. Now he's leveling out the helicopter, bringing the throttle back in.
All right, all of these specials are going away midnight, New Year's Day. Best deal. Well, there's a lot of best deals. They're all good deals. Private Pilot 397. You can go down below right now, and if you have any questions, Heather's phone number is down below. You can text or call. We're going to give away one more. What?
Another helicopter check ride?
Another helicopter check ride for the next question. And then we're going to roll a video on our big special that goes away New Year's Day. This is something that we created. It's for a short time. We have a whole video created on that. So the question, well, that makes two questions then. Oh no, we'll have another question for the study guide at the end, at the very end. Yes, we make you watch the big presentation for the big prize. This question for this book is, what are the names of the two logbooks that are required for an aircraft? Roll the next one, Heather. Or I'll never do it. All right, people have been trying to con Heather out of one of these when they've been calling up for smaller packages. We've got a big package that's going to end first day of January. New Year's Day, this is going to end. We came up with something called the Professional Pilot Plus. This is one of the things that you're going to get with it, and we'll get more to that in a minute. But we wanted to tell you about Private Pilot Study Guide is going to be included with this course. And with the Professional Pilot, you get Private Pilot. Oh, well, let me back up. This unlimited membership never expires, and we have a new number that we've never put out before. We just counted them. We never counted all the courses together. There is over 600 videos inside HOGS in the Professional Pilot when you include Private Pilot. Oh, I'm getting ahead of myself. Also, in this package, we're giving you 3 powerful one-on-one Zooms with Brian Rutledge, our operations manager, 30-year aviator, CFI in airplanes and helicopters. People absolutely love their time with Brian. You get a free 30-minute with any course. With this one, you get an additional 3 sessions one-on-one with Brian, whether he can help you get ready for a check ride, give you career advice. There's pretty much nothing that he hasn't seen or done. So that's included with these. So we were excited today, and we looked up and we did the Private Pilot course. We'll go ahead and flip through these, Heather. Private Pilot, Instrument Pilot, Commercial Pilot, and Certified Flight Instructor, along with, we have others listed too, right? Let's go ahead and list what else is in here. Okay, so let me back up. Keep getting ahead of myself. We have course quizzes now in Private Pilot, and now, we haven't announced this yet, there is a full quizzes inside the instrument course, 144 quiz questions. Brian has spent the last 2 months building questions for the instrument courses. So now your Private Pilot has a full array of quizzes. Instrument Pilot has a full array of quizzes. Not to be confused with our written test prep that's on all the courses, but we'll get to that in a minute. Next is Commercial. We're going to start putting quizzes on the Commercial, and then we're going to put quizzes on the CFI. But as of right now, the Private Pilot course and the Instrument course both have full quizzes to cover the whole entire course. Student progress tracking on all of these courses. If you're familiar with HOGS, you already know what we're talking about. If not, if you're new to HOGS, this tracks your progress as you're going through the course. So you can see how many videos have been completed, how much of each video is completed, and then you can always then mark them if you want to come back and look at them later. So student progress tracking on all of the courses. The resume course on any device is nice because you can log out of one course or log out of your computer and then you're going to go be on your iPad. You can log back in, hit resume course, and it will take you back to wherever you're at. Mobile app, we've had that now for like 3 or 4 years. When you sign up for HOGS, look at the top of the page and there'll be a blue link where you can use that link to download the app. And then after sign up, we'll send you a welcome email that will also have a link for the mobile app. And just so you know, the mobile app and the desktop version are exactly the same. All the content's the same. Anytime we make a change inside the HOGS course, it's automatically updated in the app. So it's going to look and operate the same way. All the content's the same. It's just whether you want to view on a laptop or desktop, or you want to use your iPad or your iPhone or any of your electronic devices. So that's awesome. We haven't talked enough about these. Robinson R22 specific course is included in this professional pilot package. There's also, you know what? I'm going to grab these. We hadn't, you would think we would have known by now how many videos were actually inside HOGS. So we started writing this down. Private 195 videos, instrument 81 videos, commercial 81 videos, CFI 85 videos, R22 39 videos, R44 48 videos, Enstrom 56 videos, radio communication 23 videos. So HOGS now officially has over 600 videos in the professional pilot course. That's how much training is in there. We were kind of shocked. We knew it would probably be a few hundred. I had no idea. And we go back and look and it's like, how in the hell did we ever build 600 videos? And not only build them, but that's just what's in the site now. There's many that's been discarded and updated with new or whatever the case is. But that's how much content is with the full HOGS course. So we got Robinson R44 specific course, instrument specific course, radio communications course. As I just said, there's over 600 videos in this professional pilot. It's over 100 hours of training. Okay, so new HOGS community. We've had a community in place for a long time, but there's now a new community that they're still developing, but it has a lot more bells and whistles, and we're going to start doing more in there to get people interacting with each other. And what else? It's just hard to remember everything that we have in here over the years. It's crazy. FAA written test. Those are on all 4 courses. FAA written test practice is on private pilot, instrument pilot, commercial pilot, and certified flight instructor. They're at the end of each course because we want you to work through all the videos of each course, then do the written test at the end. And a lot of times people will email us, hey, where's the written test at? It's at the end of the course of each one. Private, instrument, commercial, CFI, those FAA written test practices at the end of each of those courses. And in the last year, we've updated all 4 of those courses. Michael Worth, HOGS superfan, has been logging in for years with our videos, used our training to get through all his ratings. I hired him, and he has been going through and updated all those courses, or those written tests. So you're not getting crappy old written tests that were written 5 years ago. He went in and updated every single FAA written test course. And along with those written test practice, you get FAA Wings credit is available, and that's if that's something you want to participate in. Our computer over here talks to the FAA computers every day. 10 a.m. it reports any scores. So whether you want to take advantage of that Wings credit or not, it's there and available. So really proud of that. So the point of what we want to show you here, and I'm using 75 an hour. So this is for ground school. If you're already flying, you know what I'm talking about. If you're brand new, you may not understand the difference yet between ground time and flight time. Flying the helicopter is the easy part. Learning all the knowledge is the hard part. There are schools now charging 75 an hour. There's schools charging less, and there's schools charging more. The last round of videos I did with Chris Hauser, I had to pay the school 75 an hour for Chris's time to help me go out, fly, do videos. That's what I paid when I needed an instructor to help me. That's a going rate now. There are people that might be more, might be less. So when you look at the big scheme of things of what you could spend, let's say at the private level, you're going to do 30 hours of one-on-one ground at your flight school at 75 bucks an hour. That's $2,250 bucks. Okay, you could cut that in half. We have some people that use do maybe half of the training with their instructor and half of it they're doing with HOGS videos, supplementing. We have people that are walking into flight school and blowing their instructors away when they walk in, they have the knowledge and they're going, what have you been doing? And they're like, well, I've been watching these HOGS videos. That's the reality of it. So when you look at, let's say that's what you're going to play at a flight school if you did, and you could do more. I had a guy once that took 100 hours of ground to get him through, but I just used 30. You might need 20, you might need 50, depending on the person. But if you're going to a flight school and you paid 30 hours for the private, 30 hours for the instrument, 30 hours for commercial, and then 30 more hours at a flight school, that's $9,000 what's going to cost you in ground school, in ground school charges one-on-one. So with our courses, with this whole entire Professional Pilot Plus, what do we say? 608 videos that you can watch repeatedly over and over and over again. They never expire. You can watch them in your pajamas, you know, eating a bowl of cereal at night. It saves you the time of getting in the car and driving to the flight school. And then, so on top of what that could save you, bonus, you get your first 30-minute consultation with Brian as a starter. Everybody gets that, whether you sign up for a monthly membership or yearly membership. We have another Pro, that's not Pro Plus, it's just Professional Pilot, that's unlimited, that's available right now. All of these you get a free 30-minute starter with Brian, and people love those just to get their jump start on the training and where they're going and what they're going to be doing. But then included with this one, you're going to get 3 really powerful Zoom sessions. We do have been scheduling some check ride prep with our members, and we have Brian do those check ride prep sessions. So we thought we'll build a package where you're going to get the 30 minutes with Brian for your starter, and then 3 more Zooms on top of that, where you'll schedule them ahead of time. He'll check your progress in the site. You guys can communicate through email or a phone call before you actually schedule the Zoom, so that he has an idea of where you're at and what kind of help you're going to need from him. Again, it could be career advice. It could be becoming a law enforcement pilot like Brian is. The things that Brian can help you with is pretty endless, considering, again, 30-year aviator, CFI in airplanes and helicopters. And Brian put this together. So this, back to the study guide. We're going to include the study guide in this Professional Pilot Plus. So it's all the courses, everything we got, unlimited, never expires. You got this 30-minute starter with Zoom, or with Brian, and then 3 more Zoom calls. Again, you'll talk ahead of time. You'll know where you're going. He'll have an idea of where you're at so that he'll be able to be prepared when you guys do your Zoom session. And then we're going to send you not only the Private Pilot Study Guide, but both copies of Helicopter Check Ride and Top 10 Check Ride Tips. Got to catch your breath. And Heather went through in a HOGS t-shirt. So there's a link down below to sign up for that. We'll expand on this just a little bit more. Brian put this together now about 1.5 years ago, and he went through the practical test standards, okay? The practical test standards is what he used to create this. And it is 180 pages, over 400 questions. And we tell people, yes, this is valuable on past private, because your commercial check ride is a private pilot check ride on steroids. It's all the same stuff and known it to a higher level. And then at CFI, you're going to be teaching this stuff. And the check rides always start out the same way. They're going to ask you, what do you have to have on you? What do you got to be current? You know, all those things start out the same way with each check ride. Brian uses this during the one-on-one time, and I've found myself using it as well now, because it's just easier to grab this than any other document or anything else that we have available to us. This is our number 1. This is the one that we go to and just sit down and start going through it. And many of you have seen these in our past videos. There's a link down below if you want to grab just a copy of this for yourself. That link is below, along with the link for this Professional Pilot Plus. So this is included again. So you get the 3 books, all this one-on-one time with Brian, the HOGS t-shirt, compliments of Heather. And this goes away January 1, 2023. This video goes away, the deal goes away. It is there and included with every single course we have, regardless of whether you're going for a monthly, yearly, you're going for a pro pilot. They all have a 30-day, no hassle, money back guarantee. So the burden is on us to provide you the value. It always has been, always will be, because we're confident in our training. We've been around approaching 11 years. March 1st will be 11 years we've been online. And I'll mention the HOGS Wall of Fame behind us. If you've never seen that, if you're new to us, the thing that keeps growing and you can't even see it all now on the camera because it's getting so damn big. That's our members. And they send us a picture after they pass their check rides. And once they do, we send them the HOGS no-go button.
Live to fly another day.
And the HOGS Wall of Fame. HOGS Wall of Fame is fun because people now email us or call or text Heather and go, I'm going to be on that wall. That's my goal, is to get on that wall. And it's something that we started about 4 years ago. And it's turned into something really, really cool. So if you have a question, all right, what you've been waiting for, the study guide. This question is so simple because we just made you sit through. This is kind of like a timeshare thing where, you know, hey, you want a free breakfast at the hotel? Oh yeah, and then they put you through 3 hours of timeshare and give you a crappy ass little breakfast. To win the study guide today, this is so simple, it's not even funny. In the Professional Pilot Plus that we just spent 15 minutes talking about, is our Zooms included with that? Yes or no? Easiest question for the most valued product probably ever given away. You can grab this down below, as I just mentioned in the previous video. There's links below this video along with the Private Pilot Special, the Professional Pilot, and then the Professional Pilot Plus. So we're just waiting on an answer, a yes or no, and as soon as Heather sees it in chat, we'll know who won. So other than that, you got a winner? Anthony, you got it. You know the drill. You've already been on there winning today. So email Heather, helicopter. Well, you're talking to her right now and you're already communicating with her. So there you go. All right. We won't waste any more of your time. We'll get out of here. All the specials end New Year's Day at midnight, and we're going to go live tomorrow. I think we're going to do some R22 or R44 stuff tomorrow. Maybe both. Just because I'm trying to break it up, talk about something different. So we'll be back tomorrow. More giveaways. So we're going to wrap it up. Go down below for all the different links, and we'll see you later on. Peace out.